So now we learn about the bistable multivibrator. Okay, why it is known as bistable multivibrator? Bistable multivibrator because it has two stable state. It has two stable state. That means both state are stable. First of all, if the output is 0, it is always in 0. Then if we apply a triggering, it goes to 1. So before apply, but without apply any triggering, it always is in 0 state. After applying triggering, it goes into 1 state, but it will also remain in this 1 state. Again, if we apply a triggering, then it will migrate it to 0 state, or then it will fetch to 0 state. So without applying any kind of triggering, we can change the state. As for this reason, it is known as bistable multivibrator. This is the basic circuit diagram of bistable multivibrator. Clear? So first of all, assume the transistor Q2 is in working state, or that is in on state. So it is in saturation. As transistor Q2 is saturation, then the output voltage will be 0 or minimum. So first of all, the output of the transistor Q2 is 0. Okay, so the output voltage here, voltage is 0. So here voltage is 0, there also voltage is 0, and this 0 voltage also come across the base of the transistor Q1. So it is in cutoff state. Okay, cutoff state. First it is in cutoff state. As it is in cutoff state, so the output voltage will be high. So take it is 1. Output voltage here is high or 1. So now if we want to change the state from 0 to 1, okay, we apply a negative triggering here. Okay, apply a negative triggering. Why negative triggering? Look, if we apply a negative triggering, okay, the voltage here will be negative, and as it is a NPN transistor, so the transistor Q2 will be in reverse bias. Reverse bias means it will be in cutoff region. Now if it is in cutoff region, then the output voltage will be maximum, and it is goes 0 to 1. Okay, but it will remain stable in this 1 state. Okay, so it is maximum. Now the voltage here is maximum, also the voltage here will be maximum. If this voltage is maximum, then it will going to saturation region. Saturation region means the output voltage will be 0. Now if we want to change this state from 1 to again 0, we apply a negative voltage across the transistor Q2 by across the base of the transistor Q1. Okay, what will be? Then if we apply the negative voltage here, then it will also be in negative. If it is being in negative, then this transistor will be again in cutoff region. Here negative voltage means transistor Q1 will be in reverse bias condition. Then this transistor Q1 will be in cutoff region. Then the output voltage will be maximum across the transistor Q1. So if the voltage here is maximum, okay, or 1, this voltage also come in the base of the transistor Q2. So here maximum voltage. Previously here low voltage or negative voltage will come. Now here positive voltage or maximum voltage is come across the base of the transistor Q2. So the transistor Q2 fetch to saturation region or going to saturation region, as this is in now in forward bias. If it is going to in saturation region, then the output of the transistor Q2 will be again in 0 state, and it will going so on. So if we want now 0 state, and it will be stable in 0 state. Again if we want to change this 0 to 1, even if we apply a negative triggering here, so before but without applying any kind of triggering, we can change the state from 0 to 1 or 1 to 0. As per this reason, this is known as bistable multivibrator. Okay, so if we want to change the state, first of all 0 to 1, we apply a negative transmission or negative triggering across Q1 a Q2, and again if we apply again a negative pulse across Q1 or base of the Q1, it will again transmission 1 to 0. So this is the basic working principle of bistable multivibrator.